Let's see what's process hollowing. You remember that we said that malwares need to hide themselves and operate stealthy. One of the approach was to rename themselves as like processes that usually exist in the operating system, like svc host.exe or explorer.exe. But after renaming, their true properties will not change. We know that svc host and explorer are in folder C, Windows System 32. A user or even and antiviruses, even the end user can notify that these processes are running from different directories, so we'll notify them. What will happen? The approach is malware use is process hollowing. What they do, they start a clean programs in a suspended mode, like notepad, calculator. And the programs, mm, they are most probably already installed in most of the operating system. They start them in suspended state and do the process hollowing. How process hollowing happen is that, for example, they launch the run the code, and obviously after running, the process will be started. For example, here svc host, they start svc host.exe, and it's gonna be in a memory, is allocated memory in a memory. What will happen, I mean in the RAM, uh, malware took the part of the memory allocated for that process and write its own code over there, and point the instruction point to the place that the malicious operation is injected. Let's see, in this example is sample 10-6. This sample start calculator in a suspended mode, and what will happen is create a section in sample and a view of it in calculator as well. And what will happen when it write the code in this section, it's gonna, since there is a view in calculator, here is also be changed. So calculator will contain the malicious operations written here. After that, it needs to change the instruction pointer to start from this place, this part of the memory. It used the get thread context and set thread context to change the instruction pointer to this place. We talked about it last session, how to, these are the thread to get the PID, which is the pointer, PIE, instruction pointer, to get it and set it in the calculator. When it's happened, it's gonna start the calculator, but instead of starting the calculator, what will happen, the malicious operation is just showing a message to the user and also creating a file, a text file named process hollow calculator.txt in the same folder that the file exists, the sample is exists. Let me show you the execution of this sample in my computer. I open the process hacker, and let's go sample 10.6. I'm gonna run it. It said check the created sample. We have a sample, and it's start calculated in a suspended mode. And I'm gonna open these two to check their memory. Yeah, it said press any key. I'm gonna do that. It said that it created an injector in an injector process at address FC. It's in the FC. It's created a memory section FB. Let me see. FC FB C. There's FC. FC. Let me find it here in 5A 5A 5A. Let me. Okay. Okay. FC here is created, and in calculator it said the address is mapped is 5A. Let me see in the calculator 5A. This is the address. You see it's read or write and exe, and it's a type of map. And here it's again read or write exe, and it's mapped. If I press continue, it's gonna sample 10 already executed and show. Let's see what happened. Let me see. Okay. Is calculator process hollowed. Let me see if the file is created. Let's try. It's supposed to create a file here. The next time, previous time I ran it, is create that file here. I have to close that one to see this file. Yes, this file is created, so it's hollowed it based on the approach that already explained you in the PowerPoint. Another approach is classical shellcode injection. While we are injecting DLL or P file, what will happen? It needs to use load library API to load the DLL, and for or P file, what it needs to load the P file has a header, and it needs to change load that header as well. And if there is any importing of any libraries, it needs to do that before running load library. So it needs to fix the import table and relocation table to match the addresses to with base address to relative address, and also so for load library it needs to load the header as well. But in shellcode it's just it doesn't have any. It's just a piece of code. It doesn't have any header, so, and it doesn't need any load library to load the that, like DLL loading the DLL or loading a file. If let me in this picture you can see that for P files or DLL, it's like it has a header, and it needs to load the whole files to the target process. But here in the shellcode, what it needs to load, it needs to load that piece of code and let the instruction code to change it, or let the instruction pointer to reach that piece of code to execute that shell code. In classical DLL injection, it needs a load library to load the DLL, and what it loads is a DLL should be is like a file in a disk, which is loading to the target process. Even if there is a the malware get the code from the internet, it's write it in a file, and after that it's use load library API to load it in a target process. When the DLL or that piece of code that should be loaded to another process is like a file in the system, is a file, not like a file, is a file in the system. It's not still C and can be caught by antiviruses. What the attackers do is that what they need to load uh, uh, get the DLL as a resource in a malware, in a downloader part of the malware, because we in the previous one we said that there is a downloader that loaded the DLL from the network to the file, and after that call the load library to load it to the to another process. If what will happen is that the malware, to be stealthy, the downloader load that DLL as a resource in a memory of the downloader, not to write in a file, in a memory of it, and instead of calling a load library, it's do the what's happening in load library to load it to another process. It means the operations which is exists in load library, it copy it and mimic that operations and load it into another process. And we know that after loading, it needs to fix the relocation table and import table. That's this process I explained, we call reflective DLL injection. Loading the getting the downloader get the DLL into its memory as a section, and then mimic the operation which is exists in load library to load the DLL to another process, to another benign process. So far we learned about some APIs that are for allocating memory. For code injection we need like allocating memory, set context, like creating section, write and map view, and adjust token privilege, and even program instruction, set program instruction with get, set, thread context, and so on. All these APIs, go through them that I have in the slide. Remember them, because after that, when for debugging, we gonna see that you need to know about them to catch the malicious part of the code. But the question is why these malicious APIs exist. It's the main reason was that for debuggers, because debuggers need to have access to another process and set a breakpoints and set instruction pointer and so on. So these process and these APIs are created to be used by debugger, and that's what malware adversary guys they take advantage of it and use them for their malware.